watched the video in the last series, okay, I've sent a link. So if you had watched the video, you would have understood how to remember this. Even if you have not watched, just pay attention here. I'll just do a quick revision. कबीर ने कनाडा में अपने जिंदादिल फ्रेंड परब को 100 कैरेट हीरे सिल्वर गोल्ड प्लैटिनम दिया. ओके, व्हाट इज द रिमार्क? कबीर ने कनाडा में अपने जिंदादिल फ्रेंड परब को 100 कैरेट हीरे सिल्वर गोल्ड प्लैटिनम दिया. Okay, so with Kabir you will remember potassium, नहीं sodium, Canada calcium, नहीं magnesium, आपके aluminium, जिंदादिल zinc, ferrum, परब, plumbum और lead, 100 hydrogen, carat, cuprum, 100 carat, cuprum और copper, हीरे, hydrocarbon, silver, Ag, and gold, Au, that is all दिया. So this is how you remember the metal activity series. Okay, so once you remember the metal activity series, you need to understand that the metals which are placed on the top are the most active metals. So as you move up, the activity will increase, but if you move down, the activity will decrease. Okay, so as you move down, the activity will decrease. What does this indicate? This indicates that the most active metals are placed on the top. Who's the most active? Potassium and sodium will be placed on the top. Okay, and they are the most active. But as you come down, they become least active or least reactive. So that's the reason why gold is least reactive and it is expensive. Okay, because say for example, even if you dip a gold ring in water, or even if you go wearing gold ornaments, even if you go for a steam bath, gold is not going to react. Gold does not react with oxygen present in the air, but these elements, they react with moisture, oxygen present in the air, moisture or oxygen present in the air, and that's why they are cheap. Okay, and they are explosive also, so they are highly reactive. So potassium is the most active in this series, and gold is the least active in this series. Okay, so as we move down, the reactivity decreases. I've told you, as you move up, the reactivity increases. That also we have discussed. Then arrangement of metals in the decreasing order of reactivity in the form of series is called as the reactivity series of metals. Now you have understood the reactivity series of metals. I would also like to go back and tell you that metals which are placed on the top will be able to displace the metals which are placed at the bottom. But the metals which are placed at the bottom will not be able to displace the metals which are placed on the top. So what do you mean by this? Have a look over here. Okay, so say for example, we are having copper sulfate plus zinc. So zinc is able to displace copper because zinc is placed above copper in the metal activity series. So zinc can displace copper, remove copper, combine with its partner sulfate, form zinc sulfate and give you copper. But on the other hand, if I react copper plus zinc sulfate, now copper is not able to displace zinc because why? Copper is placed below activity series. See, where is copper and zinc placed over here? Check. Copper is placed below zinc in the metal activity series. You can see that. Here is zinc, here is copper. So zinc can displace copper, but copper cannot displace zinc. Okay, so this is all about the metal activity series. Now we are going to talk about the reactivity or chemical properties of metals. Further, we are going to talk about reaction with oxygen. So almost all metals are able to react with oxygen except for gold. Okay, gold does not easily react with oxygen. That's why it's called as a noble metal. So what will be the reactions? Reaction with oxygen will be like say for example Na. You are reacting Na. Can you see this link over here? Just check. Na. Able to see this? Yeah. Na plus O2 will give you. Now how to do this? You know crisscross method, right? Na is having a valency of +1. Oxygen having a valency of -2. Okay, oxygen having a valency of -2. So 2 will come over here, 1 will come over here. Okay, so we write Na1 and sorry Na2 because 2 is going to go to Na and 1 is going to go to oxygen. So Na2O. Okay, Na2O1 or you simply write Na2O. So what will be the reaction? What will be the product? The product will be Na2O. How do you balance it? We balance it like these 2 oxygen atoms over here, so you have to write 2 over here. So 2 2s are 4, that is 4 Na plus O2 gives you 2 Na2O. This will be the reaction of metal plus oxygen. Metal plus oxygen will give you metal oxide. I've given you an example. Sodium plus oxygen gives you sodium oxide Na2O. Okay, K plus O2. Now come and try doing, pause the video and try doing it on your own. K plus O2, again perform that crisscross. Okay, K is having valency +1, O is having valency -2. So with the help of these radicals and crisscross method, try solving it. You should get the answer as K2O. Okay, again 4K plus O2 will give you 2K2O. This is how you react potassium and oxygen. With sodium, I've already told you, sodium and oxygen will react with 2Na2O, that is sodium oxide. Okay, then magnesium does not react with oxygen at room temperature but on heating. See, now sodium and potassium are on the top, so they are reacting without heat. But as you come down, the reactivity goes on decreasing. So magnesium will not directly react at room temperature. It will react only at higher temperatures. And how will it react? Come on, you try solving it. Mg plus O2 gives MgO. So how did you know that? Because magnesium is having a valency of +2, oxygen having valency of -2. You do criss and cross, you get Mg2O2. 2 and 2 will cancel. And what should be the product? MgO. In order to balance the oxygen atom, there are 2 over here, 2 MgO. And because magnesium has also become 2, in attempt to balance the oxygen, magnesium had become imbalanced. So we write 2 Mg over here so that the reaction gets balanced. So Mg plus O2 will give you MgO. But this is going to happen only after you provide a little bit of heat. Now this is a little interesting because initially when you provide heat to magnesium, magnesium starts burning with a dazzling light. Okay, in case of sodium and potassium, it can happen at room temperature. You don't need to heat. It can happen at room temperature. If you keep open sodium like this, just open like that, it can react with the oxygen, react with the moisture present in air and explode on its own. But magnesium will not be able to explode. Why magnesium will not be able to explode like that? Because magnesium will not react with the air. Okay, unless and until you heat. It will not react with oxygen unless and until you heat it. So only after you heat it, it will produce white dazzling light. Okay, and along with white dazzling light, along with it's an exothermic reaction also, obviously. All these are combustion of metals. All combustion reactions are exothermic, right? So it will produce 2 MgO, but along with a lot of heat and light. Along with a lot of heat and light. Okay, so zinc burns in air only on strong heating to form zinc oxide. Okay, so zinc in presence of oxygen will form zinc oxide. Okay, again it requires even stronger heating than magnesium. अभी दिवाली में आपने फायर क्रैकर्स लिए होंगे और फायर क्रैकर्स अगर आपने बर्न किए तो कुछ फायर क्रैकर्स में मैग्नीशियम हो सकता है. इट विल यू प्रोवाइड अ लिटिल बिट ऑफ हीट एंड विल स्टार्ट बर्निंग विद dazzling white light. बट कोई भी फायर क्रैकर में जिंक नहीं होगा. क्यों जिंक नहीं होगा? बिकॉज जिंक कैन नॉट बर्न ऑन इट्स ओन लाइक दैट. Okay, zinc will not be able to burn like that because zinc requires very strong heating to give you zinc oxide. Right? Zinc requires very strong heating to give you zinc oxide. It's not balanced. 2 oxygens on the left hand side, 2 oxygens on the RHS because we have multiplied this by 2. 2 zinc atoms on the RHS, but only 1 zinc atom on the LHS. So we'll have to add a 2 over here in order to balance it. Okay? So this is zinc oxide. Now come on, have a look at this ion. It won't even burn. It won't even combine with the oxygen even after strong heating. But ion fillings burn vigorously, not iron bar, and iron fillings will be burning vigorously when you turn on the burner in presence of strong heating. They will form what? Iron oxide, right? What is it forming? Iron oxide. Can you see the color change? Okay, here iron was in the original color, but after burning, you can see that it has turned to reddish brown. Okay, and that reddish brown, if you want to zoom it a little, right? It has turned what? Reddish brown. Okay. So, because the reddish brown color is because iron from the zero oxidation state has converted into. Sorry, I don't need to do that. It's like yeah. Let's move on to the next slide. Just a second. Yeah, here we go. So it has converted to reddish brown because of FeO. Oxidation state of iron has become +2, and that's the reason why it is changing its color from the normal color of iron, that is that silvery black color, to reddish brown. And now it has changed its color. You can see over here. Now it has changed its color to black. On further strong heating, it has changed its color to black. Now, why does this happen? The reaction is because initially it converts into FeO, which is the reddish brown in color. But if you further continue to heat, strong heating if you do, it will convert into Fe3O4, which is iron oxide. Which is what? Iron oxide. Okay, 3Fe plus 2O2 gives Fe3O4. Please write down the reaction. 3Fe plus 2O2 gives Fe3O4. That is iron oxide, which will be black in. Okay, now we are heating copper. So copper is this. See, now we have moved down. You know, initially we heated sodium, potassium. Then we heated magnesium. So sodium and potassium were able to react with oxygen without heating. Then magnesium was able to react with oxygen only after heating, not at room temperature. Then zinc was able to react with oxygen only after strong heating. Now, and you come down further now, was not able to react with oxygen at all even after strong heating. But if you use iron filings is powder of iron. If you use that, then only it will be able to react first to FeO, iron oxide, iron 2 oxide, and then iron 3 oxide, that is Fe3O4. It converts it from reddish brown to black. And we now move even below iron, below Fe. So when we move below Fe, we are moving to copper. Copper does not burn on heat. The hot metal is coated with a black layer of copper oxide, but it does not react easily. Okay, so copper with oxygen will form copper oxide. Okay, copper 2 oxide. And after it forms copper oxide, this black layer of copper oxide is formed on the surface. It's only on the surface. Even if you rub this, it will go off. The black color will go off. Okay, so here we can see that aluminium plus oxygen, again aluminium does not easily react, it will react only after strong heating to form Al2O3. Okay, again we need to balance this 2 2s are 4, so this 4 over here, 2 3s are 6, so after write 3 over here, so that it becomes 3 2s are 6 balanced on both the sides. Okay, yeah, so you can see that these metals which are the most reactive are able to react at room temperature. These ones after heating, this one after strong heating, this one after heating only in the form of fillings or filings, powder. Copper, very strong heating, and below that the metals don't react with oxygen at all. Okay, so here chemical properties of non-metals now, metals only with water. We reacted with oxygen first, now we are reacting it with water. So the metals which are placed on the top are highly active, right? They can react even with cold water, like metal plus water. Okay, the metals which are on the top, mind you, it's sodium potassium, can react even with cold water. They give you metal hydroxide plus hydrogen gas. They produce hydrogen gas. Hydrogen gas is a gas which burns with a pop sound and a blue flame, and it can also extinguish a glowing splinter. It's a neutral gas to hydrogen. Okay, burning with a pop sound. And metals with hot water produce metal hydroxide plus hydrogen. This is for metals which are not sodium potassium, which are below sodium potassium, like calcium, magnesium, and all. Then metals plus steam will form metal oxide. Now, metals like aluminum iron will not even react with hot water. They will be reacting only with steam to produce what? Metal oxide plus hydrogen gas. Okay, most metal oxides are insoluble in water, but some of these dissolve in water to form alkalis. Okay, potassium sodium oxides dissolve in water to produce alkalis as follows. Okay, so you can see potassium oxide with water will produce potassium hydroxide. Okay, and sodium oxide with water will produce sodium hydroxide. These oxides dissolve in water to produce what? Alkalis, because these oxides which are being formed are basic oxides. Okay, but before that, before we move ahead, I want to show you how these metals are reacting with water. Okay, how the metals are reacting with water. So our metal activity series you can see very well. कबीर ने कनाडा में अपने जिंदा दिल फ्रेंड भरत को 100 कैरेट हीरे silver, gold, platinum. The platinum is again an inert or noble metal, same gold. Okay, so talking about these two, these are the most reactive, right? So they are reacting even with cold water. Like let me give you an example. K plus H2O will give me KOH plus H2. Same goes with Na. Na plus H2O will give me NaOH plus H2. So how are you doing this? Have a look. This water will split up. It's cold water, mind you, it will react with cold water. Don't need to heat water. These metals are super active, the most active metals on earth, right? So H plus and OH minus. What will split with H plus and OH minus? This is Na. Na will combine with OH, forming NaOH. Then hydrogen will H plus ions, 2 H plus ions will combine to form H. So we need to balance this equation at the moment. So how do we balance this? Like 2 Na we'll have to take 2 Na and 2 OH, 2 H plus 2 H2O, right? So 2 Na will combine with 2 OH to form 2 NaOH, and 2 H plus ions will combine to form H. Same goes with potassium over here. 2 K plus 2 H2O will give us 2 KOH plus H, hydrogen gas. So these are able to react with metals at room temperature, rather even with cold water, they are able to react and they are able to release hydrogen gas which burns with the pop sound. Now when we go to calcium, or let me check out with magnesium. Magnesium will not react with cold water. It will react with water, but the water should be hot. Okay, only with hot water it will react, not react with cold water. It will again produce the same thing, that is hydroxide, magnesium hydroxide plus hydrogen gas. I hope you know how we had combined Na plus and OH minus. Both are having 1 1 valency, they had combined to form NaOH. Similarly, when we are trying to combine Mg and OH, I hope you know that Mg is having a valency of +2 and OH is having a valency of -1. After doing criss and cross, we get MgOH twice, and that's the reason why I have written MgOH twice over here. Wherein I have to take 2 H2O, 1 Mg plus 2 H2 to MgOH twice plus H2. So only thing, the water should be hot. Then when I'm reacting with aluminium, aluminium is not going to react with hot water at all. It will react with water only when water is in the form of steam, high temperature, not hot water, even hotter than water is what? Steam. Okay, remember that we have, according to the Merck index, we have some range. Like what is cold? When I say cold, the water is between 0 to 5 degrees Celsius. When I say the water is cool, okay, so when you say cool, it's between 8 to 15 degrees Celsius. When I say it's warm, okay, so it's 40 degrees Celsius, 40 to 50 degrees Celsius. Then when I say it's hot, then it's above 60. And when I say it's steam, that means it's crossed 100. So in this, it's not going to form hydroxide. Mind you, it's not going to form hydroxide. It's going to form metal oxide, and Al2O3 plus H2. Okay, Al with a valency of 3 plus oxygen with a valency of -2. Criss and cross will get Al2O3. Okay, Al2O3. But we need to balance this, right? So if you take oxygens over here, how many? 3. So if you write 3H2 over here, you will get 3H2 over here. And oxygens are balanced, but aluminium you have to write 2Al. 2Al plus 3H2 gives you Al2O3 plus 3H2. Hydrogen gas is released in all the cases, but this time metal is reacting with steam and not with cold or hot water. Same is the case with Fe. Okay, Fe also reacts with steam only. Okay, so with steam it will produce Fe3O4. Okay, Fe3O4 plus H2. So we need to balance this. Fe3O4, 3Fe plus 4H2O gives you Fe3O4 plus 4H2. Hydrogen gas released in every case. Right? We are also simultaneously we are doing how to produce hydrogen gas, because in near future we are going to require a lot of hydrogen gas. Our fuel, our next source of fuel is going to be hydrogen. In fact, the source of fuel in sun, which is like 13 lakh times greater than the earth, is hydrogen only. And our road and transport minister Nitin Gadkari has told that by the year 2024 we'll have almost all our cars working on hydrogen. Himself driving a hydrogen car, or a car based on fuel which is working on hydrogen, Toyota Mirai. Okay, then another car which is produced by Honda, fuel cell. So these cars will when produced on a mass, you can say on mass production, you will get these cars at a cheaper rate. Right now they are between 60 to 65 lakhs, but when they are produced at on a greater scale, the prices will reduce. And according to this prophecy, we can say that they will be able to, give it to the masses by 2025. Okay, so now nature of oxides. The oxides which were formed over here, where the oxides we had formed over here, K2O, Na2O, these were the oxides, these were the basic oxides. The oxides can be of 4 types. They can be acidic, basic, neutral, or amphoteric. Okay, oxides can be of 4 types: acidic, basic, neutral, and amphoteric. So if your oxide is a basic oxide and you react it with an acid, if your oxide is a basic oxide and you react it with an acid, you get salt plus water. So metal oxide plus acid will give you salt plus water, because metal oxides behave like a base. So when they react, base is your metal oxide. When they react with acid, it will give you salt plus water, neutralization reaction. Okay, so metal oxides are basic in nature. Exceptions Al2O3 and ZnO. These are amphoteric oxides, just like the word amphibian. What do you know by the word amphibian? Amph meaning both, which can like amphibian is an animal which can live on land as well as in water. So amphoteric is a metal oxide which can react with an acid as well as base. It can do both the things simultaneously. It can react with an acid as well as base. Okay, so that's amphoteric. But non-metal oxides are acidic in nature, like CO2, SO2, NO2. These are acidic oxides. Non-metal oxides are acidic, metal oxides are base. Metal oxides will react with an acid, because metal oxides are bases. Bases always react with acids to form salt and water. Okay, whereas if you see non-metal oxides, non-metal oxides are acidic, and they will obviously react with the base to form salt and water. Yeah, so here you can see that aluminum oxide, I told you, this metal oxide is amphoteric, can react with acid as well as base. Okay, so Al2O3 is behaving like an acid, is reacting with the base to form NaOH2 plus H2. As I told you that it is amphoteric, it will be able to react with an acid also, like Al2O3 with HCl. Because it is amphoteric, it can react with both base as well as acid. This is an acid, hydrochloric acid. It will react with an acid also to form AlCl3 plus H2O. So we have like how many? 3 2s are 6, 6Cl, 2AlCl3, 2 and 2 balanced, 6Cl, 6Cl balanced, 3H2, that is 3 to the 6, 6 balanced, oxygen is also balanced, everything is balanced. Okay, so this is what? This is a reaction wherein aluminium oxide is able to react with an acid as well as a base. With an acid as well as a base. Okay? Yeah, here is the reaction. Al2O3 with HCl is AlCl3 plus water. It's an amphoteric base. Amphoteric metal oxide. So even zinc oxide will be able to do that. If it is amphoteric, it can react with acid as well as base. Okay, now chemical properties of metals, reaction with water, highly reactive metals, we've already done this. Check out. Haven't we done it on the notepad? Metal plus water produces metal oxide plus hydrogen. We have done K plus H2O gives you KOH plus H2. We've already done this. Sodium also we have done, right? Then we have also, just look at this experiment. This is your metal. When it's put in water, you can see that it started floating. Initially it did sink, but see, initially it did sink. leave it up. It didn't sink, but suddenly it starts rising and starts moving around. Why? Because this metal produces hydrogen gas. The hydrogen gas bubbles got stuck to the metal, and because it got stuck to the metal, they made the metal lighter, because hydrogen is lighter than air, and that's the reason why it got buoyancy and it started floating. Okay, you can see that foam is being generated, bubbles are being generated. So calcium reacts less vigorously with water, and sufficient heat is evolved to catch fire. Okay, so calcium starts floating because the bubbles of hydrogen or gas, hydrogen gas comes stick to the surface, and hence it starts floating. That's what I told you. Ca plus H2 gives you CH twice plus H2. If you have not done this statement right now, okay, Ca plus H2 gives you CH twice plus H2. Then you've also done magnesium with water, hot water. I told you to not react with cold water, it reacts hot water. Here's the reaction. Okay, MgH twice plus H2. We've done this. Then, yeah, for the metals that do not react with hot water, we have to arrange the particular apparatus. Now here is our burner, here is our stand, here is our test tube, here horizontal. Here is our glass wool. Glass wool is a special kind of substance which has absorbed moisture. Right, moisture इसमें है, उसको water में dip किया है, soak किया है, glass wool को soak किया है water में. हम लोग उसको क्या करने वाले, heat करने वाले. And here is our metal like aluminium, Fe or zinc, which does not react with hot water, it will react only with steam. What is the source of steam? This glass wool which is having water is the source of steam. We start heating it. We started heating it. Now, after we started heating it, it will start producing steam, and this steam will react with the metal. When it reacts with the metal, it will form into metal oxide, not metal hydroxide, mind you, it will form metal oxide, and hydrogen gas will be collected over here under the bottom. Hydrogen gas is always collected under the bottom. Although it is lighter than air, it is not collected by downward displacement of air, because with air it forms an explosive mixture. Who? Hydrogen. So that's the reason why we are collecting it underwater. Kisko we are collecting it underwater? Hydrogen. Okay, so here you can see that the steam has started to eject from the glass wool. This steam will react with the metal oxide, and after reacting, hydrogen gas is being produced. You can see bubbles of hydrogen gas over here. Hydrogen gas will be collected over here. Okay, it will displace the water, and hydrogen gas will be collected on this top way. So what is the reaction? Glass wool I've told you. Okay, metal plus steam gives you metal oxide plus hydrogen. This also reaction also we have done. Air plus H2 gives you Al2 3 plus H2. We have done this and we balanced it also. Check. Then Fe also we have done. Formed Fe3O4, balancing check. We have done the balancing also, and balancing also was okay. So let us stop over here and continue the chemical properties of metals, that is reaction with water, low active, low reactive metals, in our following class.